ברוכים הבאים לקולוקוויום של המחלקה לחינוך ופסיכולוגיה, ואנחנו שמחים היום לארח אצלנו אורחת שהגיעה מארצות הברית, אורחת ישנה חדשה, שהגיעה מארצות הברית אצלנו לביקור במסגרת סדרת ההרצאות שמקדימות את כנס צ'ייס, האדם הלומד בעולם הטכנולוגי, שהתקיים מחר, כנס למחקרי טכנולוגיות למידה, ובמסגרת זו היא הוזמנה לתת הרצאת אורח בקולוקוויום של המחלקה לחינוך ופסיכולוגיה. פרופסור ברברה טברסקי היא פסיכולוגית קוגניטיבית שמחקריה מתמקדים בזיכרון, קטגוריזציה, חשיבה מרחבית ושפה ותפיסת אירועים וקוגניציה, תוך הדגשת יישומיהם לתחומי מדעי המחשב, העיצוב, גיאוגרפיה וחינוך. היא פרסמה בנושאים אלה עשרות מאמרים בכתבי עת מובילים. פרופסור טברסקי עברה את מסלול הלימודים האקדמי שלה באוניברסיטת מישיגן, ולאחר מכן הצטרפה לסגל אוניברסיטת סטנפורד, בה שימשה פרופסור בחוג לפסיכולוגיה עד פרישתה. כיום היא ממשיכה לנהל מחקרים בסטנפורד, וכן מלמדת בקולומביה טיצ'רס קולג' בניו יורק. לברברה יש שורשים ישראלים עמוקים. בסוף שנות ה-60 היא הגיעה ארצה בעקבות בן זוגה עמוס טברסקי, זיכרונו לברכה, המוכר לכולנו או לרובנו בזכות מחקריו עם דניאל קהנמן, שזיכו אותו אחר כך בפרס נובל. היא לימדה באוניברסיטה העברית, בחוג לפסיכולוגיה, בסוף שנות ה-70. בחוג לפסיכולוגיה. בסוף שנות ה-70 היא ובן זוגה עברו לארצות הברית. ברברה דוברת עברית מעולה, ואף שאלה אותי אם אפשר שתרצה בעברית. הצעתי לה להרצות בכל זאת באנגלית, בה היא חשה נוח יותר. היום תרצה ברברה כאורחת הקולוקוויום שלנו בנושא Gestures for Thinking and Talking. ברברה.
תודה לכם על הרוח היפה, נורא נחמד להיות כאן. Okay, everyone gestures. The question is why, and there are lots of answers. What are gestures good for, or if they're good for anything? Some people think that they're completely useless. They have no function for anybody. They're just there. But other people argue. There are violent arguments in the literature about whether gestures are functional, whether they serve some use, and if they serve some use, are they useful for communicators, the people who are using them? Are they useful for the people that are seeing them? And if they're useful or functional, how and what? So there is some evidence that they're useful for the people that are using gestures. And some people think that's the only use they have. So if you sit on your hands while you're talking, it's harder for you to find words, okay? Especially when you need words for spatial things, for describing where things are in space or where things are in time. And from that, people argue that gestures are functional for lexical retrieval, for finding words. Okay? However, or in addition, blind children gesture. Okay, children who are born blind, especially when they're explaining where things are in space, use gestures. Now, they've never seen their gestures. They don't know that others are seeing their gestures. They've never seen gestures of other people, but they gesture. And it's as if the gestures help them think about space. So it's possible that gestures are functional not just for finding words, but for thinking at least about space and maybe other things. So there is very solid evidence that gestures are useful for communicators. There's some evidence that they're useful for recipients, that recipients understand messages better when they can see the gestures when they can. But there are still, as I say, strong arguments. People yell, right, at each other about what their uses are. So what I'd like to describe today is several experiments that are going on in our laboratory. They're each done with different graduate students that have investigated gestures in a number of contexts, and we'll address those questions. So if gestures are functional, they may serve to, or we're going to show that they serve to organize thought. They serve to pick out things in the world by pointing. You can make clear what thing you're talking about by pointing at it. Those are deictic gestures because deixis is the word in Greek for finger. So from that comes the word deictic. Gestures can depict or demonstrate and enact. In other words, they form an iconic function. They can look like the thing that they're representing. You say a big fish. And we're going to try to show that gestures can create mental models. They can create physical models that help the recipient and maybe the speaker form mental models. So first, the research that we're doing is based on research of many other people. Dave McNeil is one of them. He's one of the first people that brought gestures into psychology as a serious study and developed some of the ways of coding gestures. His colleague at University of Chicago, Susan Goldenmeadow, has written a book about 4 years ago on gestures. It's an easy book to read. It's wonderful. And she has lovely applications of gesture to teaching, to education. She looks also at communities that develop gestural languages and how they develop sign languages. So I'd like to recommend their work to you, especially Susan Goldenmeadow's book. So kinds of gestures. One very common kind of gesture is what's called an emblem, like okay. And these stand for words. So they function exactly like words, and they differ across languages, but although okay is probably pretty universal, but they function like words. Another kind of gesture is something that's called a beat. So you say on the one hand, on the other hand, or you say first, second, third. Those are beats. I'm not going to be interested in them today. There's a very interesting literature on them because they serve to break up discourse into one point, another point, and can help people understand the discourse better. They can also help you, when you're speaking, divide up the discourse. So the beats serve to divide up the discourse. Next we have the deictics. I already said something about them. They're pointing gestures. And they bring the world into a conversation. By pointing at things in the world, they make the world part of the discourse and make it more comprehensible in that way. So we will be talking about deictics. We'll also be talking about iconic gestures, which resemble the things that they're trying to convey, and metaphoric gestures, which metaphorically resemble the things that they're kind of trying to convey. So you might say somebody's at the top of the class, right? And you mean that they're at the top metaphorically, but you use a gesture going up, okay? So many of these kinds of expressions, metaphoric expressions, are in language, spoken language, as well as gestures. So we'll talk mostly about the deictic, the pointing, and the iconics, the ones that resemble, and a little bit about metaphoric resemblance as well. But those are the basic categories of gestures that have been studied. There are more, and subcategories of those. Okay, so again, I'm going to talk about 3 projects. The first one looks at gestures in thinking and explaining, and that's with a current graduate student of mine at Stanford, Angela Kessel. The second project looks at gestures in collaborating at a decision-making task, and that's work with a former graduate student, Julie Heiser, and the data aren't yet analyzed completely, unfortunately, but I'll tell you a little bit about it. The third project is gestures used in explanations. It will tie up with some of the things I said yesterday, and that's work with another graduate student, Sandro Lozano. Okay, the first project. This is gestures for thinking with Angela Kessel. In this study, students were brought into the laboratory, each one at a time, and they were asked to solve 6 spatial problems. I'll show you those in a minute. And they had a certain amount of time to solve the problems. If they didn't solve them, then they were told the answers. And they solved the problems alone in a room, all by themselves, door closed. But they were filmed. We filmed them. And then they were told to explain the solutions to the video camera. So they gave an explanation of the problem to the video camera, and the explanation they were supposed to give was to tell other people how to solve those problems. Okay? So we picked spatial problems because they're known to elicit a lot of gestures. So I'll show you some of the problems. Don't worry about solving them. There were only 1 or 2 that our students could solve. Okay? So I'm only going to talk about the analysis of a couple of these. So they aren't. Most of them aren't important. So this one was 2, and they didn't get pictures. The pictures are here for us. Okay, so there's $1 in the bottle, and the task is to remove the $1 from the bottle without removing the cork or breaking the bottle. And I don't remember the solution to that. Okay. The next one is the wire problem. Angela spent a lot of time looking through books finding these. So the next is the wire problem. And here's a wire wrapped around a tube. And you're supposed to find the diameter of the wire using a dowel and a ruler that measures in inches. So that's, again, I don't remember exactly the solution. The radiation problem is a famous problem in psychology. You probably all know it. This is a problem that was used first, to my knowledge, by Dunker in the 30s, long before radiation was used for cancer. And the issue is to use radiation to kill the tumor without killing the patient. How do you get lots of rays into the body inside the tumor? If you use all the rays from one position, then the body dies, and the solution is to bring rays from many different positions, and this is in fact the medical solution that's used. There are many analogs to this problem. It's been widely studied in problem solving. It's a good problem because people in general eventually solve it, but not everybody, so there's a lot of room for manipulations. It's a great problem. Okay. The two ropes problem was invented by Norman Maier. It's studied still in organizational psychology, and this again is a depiction. They had no depictions. There are two ropes in the room. You can't bring them together. They're too far apart. You can't bring them together. Your task is to tie them together. There's a lot of stuff lying around in the room, and the solution is to, and watch my gestures, the solution is to tie something, some pliers or something to one of the ropes to set it swinging. Okay, so it's acting like a pendulum. You grab the other rope, and then you grab the other one when it's swinging, and then you can tie them together. So this, again, is a famous problem.
This was used, I think, to create a term to test functional fixedness.
Yeah. And it's used in functional fixedness. That was Maier's point with it, and it's used in teaching businessmen, graduate students in business to be more creative, to think more creatively. So it's, again, a well-known problem. This one is a bit of a red herring in the sense that it misleads people, and so it's a good problem too, and I will talk about it. It's the ladder problem. The ladder has 10 rungs. The distance between each rung is 12 inches. The lowest rung touches the water. Because of the incoming tide, the surface of the water rises 4 inches per hour. How soon will the water cover the third rung from the top rung of the rope ladder? So people, you'll see, try to solve this problem. They use gestures. Almost nobody gets this one right. But they try to solve it in the wrong way, and their gestures are interesting. Okay, this one people generally solve too, and will be of interest to the discussion today. You have three glasses that are full, 3 that are empty, and your job is to only move one glass and to make it so that it's empty, full, empty, full, empty, full. Okay, you only can move one glass. By handling only one glass, change the arrangement so that no full glass is next to another full glass and no empty glass is next to another empty glass. So this is a kind of insight problem. People suddenly get the solution, and most of our students solved it, not 3/4. Okay, so this is showing you some of the data. So as I said, let me just, before you start looking at that, we did have the video camera on while the students were solving the problems. As I said, they're alone in a room. And for 2 of the problems, they're gesturing. Now, most of the people that have studied gesture came out of the speech literature. They were studying language anyway. They were psycholinguists. And they noticed that when people talk, they gesture. Psycholinguists are very biased towards words and towards syntax and formal properties. They're also biased toward text. Where text you can't use gestures. But text is not a normal way of communication. Communication developed face-to-face in small communities, or language did. And language always uses gestures. So studying gestures was often not taken seriously by people who studied language because it doesn't have these formal, nice properties like syntax or even a formal semantics. And it looks random. People sometimes do it, sometimes don't. Hand waving, that's what they thought. So very little work has been done on looking at gestures when people aren't talking. They thought that gestures were just an accompaniment to talk. But it turns out that gestures are used alone in a room in silence. Okay, people aren't talking, but they're gesturing. And so then it becomes interesting. Why are they gesturing when they're not talking to anybody? All right? And they're not communicating. What are the gestures doing for them? So that's what Angela and I stumbled on. We found that, so these are the proportion of participants who are gesturing. These are each of the problems, the radiation, bottle, ladder, glasses, two-string, and wire problems. Here are the proportion of students who are gesturing when they're explaining. So you can, and it gets up, it goes between 78% and 98%. So you can see that in explanations, almost everybody gestures. When they're explaining to other people how to solve the problems, they gesture. So they clearly think the gestures are useful for you to understand, okay? So that they're doing it when they're explaining. It's probably also useful for them to construct the explanation, okay? So both those things are happening here. But these light lavender bars are for gestures when they're thinking, when they're solving the problem. And you can see that two problems elicit gesture. The ladder problem and the glasses problem. The other problems don't, or elicit very few gestures. Very few people are gesturing. But a good percentage, 65%, 70%, are gesturing when they're solving the ladder problem and the glasses problem. And then the question came, why? Why those two problems and not the others? So what's common to those two problems is high spatial working memory. In the ladders problem, you have all those rungs, and the students are trying to solve it using the rungs. Again, that's the wrong solution because the boat floats, right? So the level isn't going to change. The water is going to be at the same level on the ladder no matter whether the tide is in or not. But people think that the rungs on the ladder and the space in between them is relevant, so they're doing this sort of thing I'll show you in a minute. The glasses problem has 6 glasses, and one has to be moved. Okay? So that's in both of these cases, you're exceeding working memory demand. In all the other spatial problems, you're not. The 2 strings is just 2 strings. The coil around the stick is just 1 coil around the stick, and so forth. So there isn't a heavy working memory demand. In these 2 problems, there's a heavy working demand. What's more, it's spatial working memory. So we have some studies designed now to see if it's actually functional. In other words, if we prevent people from gesturing, are they going to be less likely to solve problems that have a high working memory demand, and in particular a high spatial working memory demand? So I don't have the answer on that yet. A student promised to do it for an honors thesis 2 years ago, and she disappeared on us. But we think that's the reason. So watch this guy gesture. He's solving the 3 glasses problem for himself. Look at his fingers. Okay, I hope you saw that. I'll show you another one. But that's while he's solving the problem, and you see that he's wiggling his fingers for 3 glasses on one hand and 3 on the other. What's interesting is in all these cases, the students are gesturing for representing the problem. When they solve it, right, they have to pour one glass to the other. That's the one glass they move. They don't gesture. They get the solution in their head. The solution itself is easy, doesn't tax working memory, and so they're only gesturing for structuring the problem. So now I'll show you his explanation. Now he turns to the camera.
The glasses take...
Watch his hands. I know you can't.
One of the full glasses that's in the middle of the other 2 and pour its water into the middle of the empty glasses and then put it back. So you got empty, full, empty, full, empty, full.
Okay, so you saw that he's using his fingers, keeping track of on his fingers. Everybody does it slightly differently. He's not making an effort to show you, so it may be serving him more than it's serving you, but the gestures are bigger than when he was solving it himself. And that's characteristic. When people are using gestures for explain, as I'm doing now, they usually make bigger gestures. When they're doing it for themselves, they're smaller. Okay, so that's one example. I'll show you another example of another student first solving the problem and then explaining it. So here she's solving. So you can see she's marking out she's checking the words and marking it out on the table. So she's doing, sometimes they do this this, sometimes they do this, right? So they do it quite differently. There's a lot, I say this because there's a lot of research looking at exactly how the hands are formed in gestures, which fingers are used for pointing, how the hand is shaped. And when you're getting at gestures for meaning, it doesn't matter so much. You can do the 3 glasses like this, you can do it like this, right? It's the same meaning. The exact hand form isn't important. So that's again, an innovation in our work, I think. Yeah, Boti. And hold that question till the end of this particular discussion, because we did that experiment. Okay, so that's for gestures for thinking. Here she'll explain, and you'll see now she turns to the camera.
The 6 glasses of water, first year full, and then the next year empty. So you take the middle glass that has water in it, and you take the water from that one.
It doesn't matter that you can't hear. You saw her pouring,
Glass that's
right?
empty. And then you put the first glass back down. So it should be full, empty, full, empty, full, empty.
So, okay, so she's then marking out what she's got in the end. So again, the gestures are telling almost the whole story. You can't hear the sound, I can barely hear it, but you saw what she was trying to do from the gestures. Okay, this is the ladder. So he's thinking on the ladder problem. You see that he's doing this on the table. And he's keeping track with his other hand of how many rungs it is. So each hand is doing a different function. Okay, that's for solving the ladder problem, which, again, they're going to solve wrong. Now let me show you when he explains it.
The rungs
Bigger gestures.
The ladder's going to be 9 feet long, as a whole foot, and then the third
And you
rung
can
from
see
the
the
top
rungs going
is
up.
going to be 7 feet up, this 9-foot ladder, because you're going to have 10 rungs.
That wasn't a
the
gesture.
8th rung, and then the 9th and the 10th, so the third rung down is going to be the 8th. There's a distance of 7 feet between the first rung and the 8th rung.
So he explains it, and then he explains at the end, first to the end, and so forth. So their explanations are nice. They give you step by step, and then they give you the goal at the end. So, and you see how hard those things are to code, because everybody's using slightly different kinds of gestures. But I think you got a feel for what the explanations look like and what the thinking looks like and how they're different. Okay, so overall gesturing, you might ask the question, are those who gesture, do they solve the problem better? And it's not, you can't unambiguously say that. So the proportion of the participants correctly solving each problem by whether they gestured while solving the problem. On the glasses problem, these are the people that didn't gesture while they were thinking. These are the people who did gesture while they were thinking, and these are all people who solved the problem. So this difference is insignificant. Okay. In other words, we can't come to the conclusion. More people gestured than didn't gesture, but just about everybody solved the problem. And the latter problem, almost everybody gestured, almost nobody solved the problem, and it so happened that the people who didn't gesture were more likely to solve the problem. Okay? And these results have been replicated by or foreshadowed by Martha Alibali, who found that often she looked at children solving, I think, math problems, and they were, many of them gestured, but they gestured the wrong solution, right? So the gesturing didn't help the problem solving. An interesting finding of Susan Golden Meadows, she has a bad terminology for this, but she looks at cases where gestures and speech aren't quite matching, where the gestures are conveying slightly different information from the speech. And she calls them mismatches, and it's not quite right because the gestures are supplementing the speech. And she often finds that the gestures are more advanced. So she's looking at kids who are gaining cognitive skills, and she finds that they can't explain certain things verbally that their hands seem to know. And to me, that indicates that there's some sort of mental model in their minds that's spatial, that they can map onto their hands, but they don't quite know how to express in words. So she finds that gesturing correctly while speaking incorrectly is a sign that the kid is almost there. Okay, But we can't conclude unambiguously that gestures help problem solution. We can just conclude that the gestures are helping certain ways of solving the problem, whether they're correct or not. Okay. So gestures for thinking and explaining, again, a partial summary. For thinking, in our studies, we found that the gestures were used for problem representation when the problem exceeded spatial working memory, and that is, they helped with the spatial layout. And you saw that the three glasses were giving you the spatial layout of the glasses. They didn't see the pictures. They had to invent that. And same with the ladder. They were reflecting the spatial layout of the rungs of the ladder. For explaining, gestures were used for two purposes, both for representing the problem, putting where the glasses are, where the ladder is, but they were also used for the solution. You didn't see that in the thinking, but they did this for the glasses problem in the explaining, but they didn't do it when they were thinking. So what we've shown here is that gestures promote thinking in the absence of communication. So they are helping the person who's making the gestures in the absence of communication. And the way they do it, we think, is facilitating, creating, and keeping track of a spatial arrangement and offloading working memory. Until we do those controlled experiments, we can't be sure if it's working memory, spatial working memory, and so forth, and we need to do those. Now, Ruti asked earlier about using paper and pencil. We ran this study allowing people to use paper and pencil. And sure enough, when they can use paper and pencil while they're thinking, they use it. And they use it only for the ladder problem and the glasses problem. They don't use it for the other problems. So they're using paper and pencil exactly where they would use gesture. And we think that supports our claim that gestures are helping working memory and structuring working memory, that supports it, because we know we use paper and pencil to support working memory. When they go to explain, they use the paper again. They use the paper in combination with gestures to explain. Okay? So that it again supports the idea that gestures are offloading working memory in the same way that paper does. So let me tell you at least about this study. The third set of studies I can skip because I talked a little bit about them yesterday. So, and we can come back to questions because the questions are really interesting. And they go beyond my research, but I know a little bit about it from other people's work. So the second project was with Julie Heiser, a former graduate student. And in this project, we were interested in how people use gestures and diagrams in a collaborative task where they have to come up with a decision. So this was run at Stanford. Stanford is prone to earthquakes, and there are all kinds of plans. In fact, I used to have to meet regularly with security people to decide on plans, what to do, how to notify the neighborhood, what to do with students in case of an earthquake, where there was food, where there would be rescue centers, and so forth. There are plans for earthquakes at Stanford, as there have to be. So what we did is we took and students are very aware of it, of what they need to do if there's an earthquake. So we took pairs of students, and we told them to imagine that there had been an earthquake, and that certain roads on campus were closed, and that people who were injured were located in certain points where they could be picked up, and that they had to figure out a route through campus that would pick up the most injured in the least amount of time. Okay, they wanted to rescue 60 people. They were given a map of the campus with the roads closed off. I'll show you that in a minute, and the number of people at each station. And they had to figure out a route, and they had to draw that route on another map. So they drew the routes, and that was part of our data. And another part of our data was videotaping them as they came to the solution. So there were two conditions. It was always two people. There were two conditions. In one condition, they worked side by side, and they had that same map of the roads closed off together, and then they drew a map, right? And they drew that together. Usually one drew and the other helped, but they did it together. The other condition, there was a shower curtain between them. So they could speak freely. They were right next to each other, no farther apart. But they couldn't see that same map. So they couldn't gesture on it. They had to do it all with language. And language is hard, even for spatial situations where we have good language. And then they drew separate maps. They agreed on the route, but each one drew a separate map. So we have those maps that they drew separately of the same route. So that's the experiment. And so we have pairs that are co-present. They're actually seeing each other, or they're separated by a shower curtain. And we're looking at the map of the route that they did. We also have all the gestures on all the on the maps, and we've begun to analyze those. But we ran out of graduate students. So this is the Stanford campus map, and here we have marked 15 people here, 8 people here, 11 here, 22 there, and then we have this road closed, 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 so they can't get through. The rescue vehicles can't get through. There's too much damage. So it turned out that finding a route wasn't hard. We needed to make it a little bit harder. All the pairs succeeded in finding a good route that would rescue the 60 people. As I say, we needed to make it. We pre-tested it many times. First we had it too hard, then too easy. Then we picked this, and it was still a little bit too easy. So we got no differences in the actual solution. We did get differences in how much time it took them to get to solution and on their maps, on the two conditions. So watch their fingers. You can't hear them, but you can see that the gestures on the map are doing all the work.
Yeah, come down like this.
You can see the routes they're proposing. You can see that they're correcting each other's routes.
Or would it be faster to go by this way?
They're picking up where one stop.
So our two options are either picking up these people and going over here, or picking up these people and going over here.
Oh wait, no. Picking up these people and going over here still.
Oh.
Did you
Or
introduce
picking up
an
this.
element of urgency here?
Just a second. Let me wait till this ends.
Yeah.
Did I introduce what?
Element of urgency.
Well, it's urgency in the sense that they have to pick 60 people in the fastest time. We're interested here in how they use the diagrams and the gestures, right? So it was urgency. In that sense, we're not interested so much in the quality of decision making. That would be another kind of experiment that we would have to. And there's a huge amount of work on urgency and decision making. On the whole, the same errors are made when it's urgent as when it's not. You get slightly different errors when it's urgent, but on that, there's literature up to here or up to here, and I'm not an expert. Okay, so I think you noticed when they were gesturing here that primarily there were these gestures that were pointing, deictic gestures, and there were gestures tracing the route. And those are the gestures that we're mostly looking at. Okay? They point to the landmarks or the collection points. They do this for the routes. And they're correcting each other. Another thing they do is they make shortcuts. So once they've got the route, then they just do the turning points. They point at each of those as like a shortcut. So you get shortcut gestures the way you get shortcut language, but this is built up inside the two pairs. They come to understand each other and imitate each other's gestures, just as we imitate each other's language, and it gets short that way. You can. We've looked at the language. The language to explain those things is terribly complicated because you have to turn left, turn right, go down. People make mistakes. They don't quite get it right. It takes them a long time to explain it. When you can trace it like that, you get it right away. It's very direct communication. So the gestures on the diagrams we think are facilitating communication enormously. We think this would work even for abstract ideas. So that if I have abstract ideas and I put them down on paper, right, I'm going to reorganize the company in this way or that way, and I put it down on paper, it's easier for you to understand. It makes the ideas public. It's easier for you to understand, for me to understand. We can change it. The other thing, then let me show you there. Here are two people working side by side, and watch them. They're not talking. They're working on different tasks. They divide up the tasks and work separately, even though it's easy to talk. Right? One is okay, and this is more of the same. You know, one is thinking here, and the other one is trying to figure out a route. You can see again on that they're alone. They're not talking, but they're using their gestures to figure out a route. They're tracing it, right? The way that you need to count money by moving money around. So they're using the gestures there. The other thing that was interesting in this condition is when one student explained a route to the other student, they gestured on the map to understand the route. not to construct it. Now, when you're both with a shared map, you can't do that. Right? I can't take the map for my own thinking. It's our joint map, and it can only be used when we're talking. Right? But when we're working separately, then I can use that map to think. I can trace it out, and they do that. So there were some interesting phenomena that emerged here. Let me tell you some of the data. Oh, here's a co-present route map. This is a map from two people working together. We had these maps rated. These were rated highly. We also made sure that they showed every turn explicitly. We counted which turns were shown explicitly, which landmarks were shown explicitly. In the co-present maps, you get that. Okay, so that's a very good map, and it's one that they worked on together. Here's another one. Oh, here are two remote maps. These are two people working side by side. They each come up. That's the same route in theory, okay? But you can see how different their maps are. You can see how much is left out here. Like all these roads are gone, right? Now they've agreed on them, but working together makes sure that your product is good. And the maps look very different, even though they work together. And it's a map. It's not something complicated, right? Or it's complicated, but not as complicated as science, for example. So the remote maps, and this isn't, I didn't pick the worst pair. This is a middle pair. So, and just representative. So the co-present, the two people working together, we looked at their ratings. They enjoy the task much more on many ratings. They're much happier working together than working with a shower curtain between them. They take much less time to come up with a solution. So even though the solutions are more or less good in both cases, the co-present group is much more efficient. The co-present group is more collaborative. If you look at the length of their exchanges, they're shorter. One person isn't dominating the conversation. They're each talking. It is a conversation. With the ones that are separated by a shower curtain, it's more like a lecture, like what I'm doing now. There are fewer interchanges, and they're longer. The co-present produce better maps. And the remote maps actually differ. 30% of the time, they have different routes. So even though they've agreed on a route together, and they've gone over it verbally, they don't have a way to check it. And 30% of the time, the actual routes are different. So it opens errors, right? And for many of these technologies now that bring groups that are it's separated by distance together in the same video room, they don't show the diagrams they don't show the gestures on the diagrams, and that's the essential information. If you remember those two people working together on the map, they weren't looking at each other. There was very little information in their faces. They were looking at the map and at the gestures on the map. That's the communication work, okay? So that what you need if you're doing these remote systems is make sure you have diagrams, because that's going to assure good communication, and make sure that you have the camera on the hands and on the diagrams. And it's not sufficient to just point. Okay, you need the deictic gesture, the iconic gestures too, the ones that are tracing the past. So there are some of these systems that allow you to point to things, but you need more than the pointing. Ruti, I'm going to wait on your question and finish. I'm going to skip the third part. So the gestures on the diagrams are critical. This is more or less saying what I just said. The participants watch hands, not faces. The gestures are carrying the message. You couldn't hear the sound, but you knew what they were doing. The critical gestures are the points and the iconic. And one technological question is how to annotate PowerPoint, how to annotate video, animations, explanations, conference situations to create better explanations. So let's see. I'm gonna end here and not tell you the next part, but because I talked a little bit about it yesterday, that you can use gestures to tell stories because they can build a mental model of space and they can build a mental model of action. So sequences of gestures are related. It's not each one alone attached to particular words, but they come in a sequence, and the sequence is quite coherent in the sense that there's the same style of gestures used one after another, and in sequence they can build a mental model of space and a mental model of action. So I'm going to skip through this, and there are films there that I'm skipping through. So why are, I'm going to end here, why are gestures so effective? So gestures, especially that third slide that I skipped, would illustrate that gestures are really effective in both, we've shown in understanding and communicating and in thinking. One reason is that they're closer to action, so that if you have action involved, like solving a problem, or space involved as in setting up a problem representation, gestures are a very natural way to express that. Why do gestures help short-term memory or working memory? I think the reason is that we remember where we put things. If you put your keys down, or your glasses down, or your clothing away, I'm not saying you'll remember, but you'll remember better than if somebody else does it for you. Okay, so the act of putting, not just telling someone where to put, the actual action of putting helps our memory of where things are. And I think this probably goes back to animals. It's pre-human. That if you've actually traversed a path, you remember it better. If you've hidden your own food, you remember it better. The actual action of putting supports memory. Okay? So that I think that's that spatial working memory or working memory has a motoric component. Right? This is hypothesis. So gestures are closer to those actions. They're symbolic putting. If I put the glasses down this way, it's symbolic putting. I remember them better. So it's embodied in my own. This is a very popular move now in psychology or cognitive science in general. Is embodied cognition. Gestures are inherently embodied. They're something we do with our body, and that they support communication. They support thinking, and they support communication, and especially because so much of our thinking is action or internalized action. So they help for the communicator. They help for the recipient. Never mind this because I didn't tell you about that. Okay. The other reason that gestures help because they're embodied. They're closer to actions. Gestures are effective, we think, because they use props in the world. So they're situated. This is another buzzword in cognition. Cognition is situated, it's embodied. By situated, we bring the environment into our thinking, into our world. And we know from all these experiments on change blindness that we don't even remember the world we're looking at. We don't keep it there. We come in the world, we keep reminding us. So if I'm using props in the world by pointing to them, they become a scaffolding, a foundation for our own thinking. Okay? So that they're situated in the sense that they bring the world into our thought processes, and we can reference the world, right, to support our own thinking and our own memory. So I think these are two of the reasons, and they're very deep reasons, why gestures are effective and why they're going to be studied even more. Because they do support thinking and communication. So with that, wait, I'm going to, never mind. We'll say I ended there. Okay?
צריך להודות בכל לברברה על ההרצאה המעולה, על המסרים הברורים, ואתם מוזמנים כולכם לעשות לשמוע את הידיים המתאימה.